This work was a collaboration between Max Planck Institute for Intelligent Systems in Germany and University of British Columbia in Canada. Over the last 3 decades, hundreds of grounded force feedback haptic devices have been invented. These devices have a wide variety of capabilities that makes them appropriate for different use cases. To find a device for a given use case, designers need to look through a long list of engineering attributes for the device. Each attribute describes one detail that may or may not greatly contribute to the overall experience or capabilities of a device. Together, these attributes form a high-dimensional space that is difficult to visualize and search and can even obscure the overall capabilities of a device. We investigated experts' mental models of GFF haptic devices to inform semantic organization of a haptic device collection. In a remote card sorting study, 18 haptics experts reviewed specifications for a set of grounded force feedback devices. After a background interview, the experts rated their familiarity with 40 devices. Next, they grouped the same set of devices according to their similarity. On our card sorting interface, the experts could drag and drop devices on the canvas. They could review detailed attributes for each device. They could add annotations to describe the groups. And they could copy a device and put it in 2 groups. Next, we interviewed them to understand the meanings for their groups. How do experts perceive similarity of GFF haptic devices? The experts varied along a spectrum. Some experts believe that each device belongs to one primary group, and they bin devices into non-overlapping groups. Others tagged many features for a device by copying it into multiple groups. Finally, some experts used a mix of binning and tagging to show device similarities. In addition, some experts used proximity to link related groups, while others perceived a hierarchy between their groups. What device attributes are important in defining the expert categories? We applied thematic analysis to the interview data and clustering analysis to the experts' groupings, which resulted in 6 key attributes and 7 nested categories for GFF devices. These attributes and categories define device affordances rather than following the literature definition of device attributes. As P5 says, I classify the devices from the point of view of the end effector or the user, not from the kinematic point of view. We redesigned an online library of over 100 GFF devices called Haptipedia based on expert categories and used hierarchy and proximity to show the relationship between the categories. An arc diagram shows semantic similarities of the devices. Users can hover over a device category or the mark for an individual device to see all the similar devices. We present semantic categories and key attributes for grounded force feedback haptic devices and show their utility for navigating and searching large device collections.